Hello guys, welcome back to this Kirchhoff's voltage law video. This is going to be the first video of this topic, and this formula or this topic is really important, especially in electrical engineering. It's probably a very commonly used formula, so it's very important that you understand how this formula works, or how it's used, where it's used, how it's used, etc. So what this formula actually means is that the Kirchhoff's voltage law, or KVL, also known as a loop rule, states that the sum of all of the voltages around any closed loop circuit such as this is equal to 0. So in conclusion, the sum of all of the voltages around the loop is equal to 0. So as you can see in the circuit, we're going to have 4 voltage drops, and all of these voltage drops are all going to add up to 0. Now, this is just a really basic circuit. The circuit probably means nothing as it's just all of resistors, but I'm just going to be showing you how it equals to 0. So in the circuit, let's say we have the voltage here, we have another voltage here, and we have another voltage flowing across here and here as well. So to generate a formula for this, which is really basic, this is just me showing you how you can generate equations from this. So from here it would be VAB plus VBC plus VCD plus VDA, and all of these are all going to add up to 0 because it's in a loop. So all of this adds up to 0. Now, you may be thinking what this actually means, so I'll be explaining it in a bit more detail now. So let's say that we have a battery, like here. Battery. This part is positive, and this is negative. And let's say that this is a 12-volt battery. So let's say that the current is going from low to high. So if the current is going from a low potential to a high potential, that basically means it's going to be plus V, plus voltage. So if it's going from a negative to a positive, it's going to be plus V, or plus 12 volts. Now let's say that we have another positive, so like that, and then let's say it's another 12 battery, and now let's say that the current is going from high to a low potential. What that basically means is that it's going from positive to negative, and that would mean it's minus V, or minus 12 volts. So if it's going from a high potential to a low potential, it will be minus V, minus 12 volts, whatever voltage is set to this battery right here. The only reason it's like this is because the current is going down. So the current is always going in one direction. It's always going to the low potential side. It always wants to go to ground. So here in this section, we'll be talking about high to low and low to high, and generating an equation from this circuit right here, which is just full of batteries, and they have each voltages, but we're not going to assign any voltages to them. We're just going to label them as VA, VB, and VC. So again, if the voltage goes from a high to low potential, the current is going to be decreasing, so it's going to be minus voltage, and the equation for voltage is V equals IR, so IR. So whatever current we calculate, we multiply it by resistance, and the voltage is going to be negative, so there's going to be a negative voltage drop. If it's going from a low to high potential, and the current is flowing towards the high potential, is going to be a positive voltage. Now, to clear something up, some people switch this around. So we're doing it this way, or my way. I prefer doing it like this, because if it goes from positive to negative, theoretically it should be minus, but some people put it as positive and they just do the opposite, which I don't understand why, but it's up to them. So let's say that we want to find the sum of all the voltages that are flowing in the circuit right here. we're going to apply Kirchhoff's voltage laws. So if it goes from a minus to a positive, that means it's increasing. So if we go back to here, minus to positive, that's going to be positive. So positive VA. Now here we're in this part now. So if it's going from positive to negative, we're gonna have minus VB. Now on this side, it's also going from positive to negative, so we're also going to have minus VC. And all of this adds up to 0. Now you can put this on the other side like this, because VA is going to be equal to VB plus VC. That's one equation you can have. So you can use both of them, but I just basically put these values on the other side, and this is just a more simpler way of writing it, but either way is fine, 1 or 2. So in this part, I've just added 2 more voltage sources over here. So here we know that we have, this is the first loop, and this is the equation that we got right. Here. So in the circuit is just a continuation of this circuit, so nothing too complex. I've just added 2 more voltage sources to this circuit, as it's just a continuation, nothing special. So here we have the first loop, and here we have a second loop. Now, you can't just add all of these together, as Kirchhoff's voltage law states that the voltages in a closed loop all add up to 0. Now here we have 2 loops, so there's going to be 2 laws. So here in this first loop, we already calculated the Kirchhoff's voltage law to be VA minus VB minus VC equals to 0, and here we're going to have to calculate it to be different. So now we want to find the law in the second loop. So here, as you can see, it's going from minus to positive, and if it goes from minus to positive, here it's going to be positive. So plus VC. Now let's go here. We have minus to positive, and if it's going from minus to positive, it's going to be positive again. So it's going to be plus VD. Now here is going from positive to negative, so it's going to be minus VE, and that all equals to 0. So in conclusion, we have multiple batteries in the circuit. This is one loop. It goes from a low to high potential, high to low potential, high to low potential. If it goes from low to high potential, it's a positive. If it goes from high potential to low potential, we get a negative, and it just continues on, depending on how many batteries or voltages we have, and it all adds up to 0. So it was always 0 if you're using Kirchhoff's voltage laws. It's always to 0. Here we have the same circuit, but this time we have 2 different loops, so we're going to have 2 different laws. So this is the first law, and this is the second law from this equation right here, and here is from here. So we have 2 laws, and we use Kirchhoff's voltage law. So in this example, we will be using Ohm's law and Kirchhoff's voltage laws to find the general equation for this circuit right here. So here in the circuit we have a battery that goes from a low to high potential and 2 resistors. So first we need to label it. So as you can see, it goes from a low potential to a high potential. So because current is flowing this way and is constant throughout the entire circuit, as it's one loop, so we'll only get one current, it's going to go from positive to negative. And since current is flowing downwards towards the negative, towards the ground, this is also going to be positive and negative, and we have no batteries obstructing current flow. So here we have Vs, so voltage source, we have resistor 1 and we have resistor 2. So to find the equation, we can either go clockwise or anti-clockwise, it doesn't matter, but here we're going to go towards, we're going to start off from the battery. So Vs, that goes from a low to high potential, that's going to be positive, so Vs. Here it goes from a high to low potential, so it's going to be minus IR1. 1. Now, because it's like this is resistance. We know current is I1, and it's constant throughout the entire circuit. So I1 is here, I1 is here as well. Here we know that the formula for Ohm's law, which is V equals IR, is again, so in here we have voltage, and voltage just means current times resistance, and because it goes from high to low, it's going to be minus IR. Here we do the same thing, but with resistor 2. We don't know the values of these resistors, so you know we're just making a general equation for this. So again, it goes from high to low, so we're gonna have I again, and then this is resistor 2, and that all equals to 0 because Kirchhoff's voltage law states that all of the voltages in a closed loop add up to 0 or equal to 0. So here we can put these values on the other side. So Vs equals I R1 plus I R2. Now here we're going to put it in a more simpler way. So we're going to put the I outside, bracket R1 plus R2. Now if you go back, you'll notice that the resistors are in series. So if the resistors are in series, this is just going to be RT. So another way of just putting it is just like this. So it doesn't really matter. We know that because they're in series, we just know that R1 plus R2 is the total resistance because they're in series.